available in India? Yes, Devmallu, if you can answer.
Sir, the connection is very poor. Can you please repeat?
No, we cannot.
Is everyone hearing? Because I am taking the class through my Wi-Fi connection. It's a Geo connection. It's not very weak here. My question is that what are the energies available in India? What are the energies available in India? This is question number one. Subsequently, I will raise few more questions.
Sir, thermal energy, solar energy, hydro energy, nuclear energy.
Thermal energy, solar energy, hydro energy, nuclear energy. Right. Is there any other form of energy? Is it coming in your mind?
Wind energy.
Wind energy.
Wave energy. Wave energy.
Geothermal energy.
Wave energy. Anything else? Sovik, আর কিছু বললে wave energy বাদে?
Geothermal.
Geothermal. Okay. So basically, these are the energy. Another energy you have missed, that is chemical energy, right? So whatever thermal energy you speak, it is basically a conversion of chemical energy. The chemical composition of coal and the chemical composition of battery cell allows the chemical decomposition to take place, from where either direct electrical energy or thermal energy is available. Am I right? Is it sensible? Do you hear me? এই আমার কথা শোনা যাচ্ছে?
Yes, sir.
So then why you are not responding, my boys? Listen, it's an online program, and if you don't respond, how do I know that you are listening, or you are responding, or you are in the system or not? I request you to answer. So can anybody tell me that in a thermal generation, how the energy conversion takes place? Where are the points of energy conversion?
Sir, boiler, turbine, and then it takes place into the shaft.
Anything else?
Sir, by heat, we convert heat energy, and after the high pressure and high temperature steam, then we convert into the mechanical energy. Then by mechanical energy, we convert electrical energy.
So there are 3 stages of conversion, right?
Yes, sir.
Now, can you bring down or break down each and every stages? I want to go into little bit,
At first,
অসুবিধা মনীষ অসুবিধা হলে বাংলায় বলতে পারো, no problem. Just I want to know whether you have that concept or not.
প্রথমে স্যার ওই হিট থেকে মানে কোলটা বার্ন করে ওখান থেকে ওয়াটারের স্টিম প্রডিউস করা হয়, সেটা স্যার সেটার প্রেসারটা বাড়ানো হয়, হাই প্রেসার এন্ড হাই টেম্পারেচার স্টিম হয়, সেটা থেকে স্যার টারবাইনে অ্যাপ্লাই করে তার হিট আর হাই প্রেসার এনার্জিটাকে মেকানিক্যাল এনার্জিতে কনভার্ট করা হয়, সেই মেকানিক্যাল এনার্জিটা অল্টারনেটরে অ্যাপ্লাই করে ওই মেকানিক্যাল থেকে ইলেকট্রিক্যালে কনভার্ট করা।
Okay, you are clear. Answer is okay, but can anybody tell it in any other way, or any further analysis, further going into details? Can anybody tell? Have bolo. Absolutely right. 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 How it takes place? No, no, no. I'm calling about turbine. ওই প্রসেসটা can anybody explain? এটা তো ইলেকট্রিক্যাল। নাও ইলেকট্রিক্যাল বয়েজ আই থিঙ্ক আনসার ইট বেটার। এর আগেরগুলো ছিল মেকানিক্যাল অ্যান্ড কেমিক্যাল।
So can you repeat the question?
I got the answer till the exit of turbine, and also got the answer that when the turbine rotates, it is mechanically coupled to the generator or the alternator also produces energy. Now there is a conversion from mechanical to electrical. Now this conversion, just I want to know that whether you are definitely you are aware of that. Now tell me how the conversion do take place. হ্যাঁ বলো। EMF generate হয়, তার মানে what it is generating? Ultimately it is generating some voltage, right? So is it when the generator is not connected to load, is it generating energy? তাহলে সম্বিত তোমরা বুঝতে পারছো যে আমরা একটা জায়গায় গিয়ে আমাদের কনসেপ্টটা একটুখানি ঠিক করে নিচ্ছি। দ্যাট ইজ বেসিক্যালি ইট ইজ কনভার্টিং এনার্জি, বাট ultimately the electrical energy where the final deliverable is that it is not delivering any energy, it is just ready to provide energy. Then what is happening to the energy spent already in this system till if I do not draw any energy from it, what it is? মানে এই যে ঘুরছে এবং জেনারেটরের টারবাইন মানে জেনারেটরের টার্মিনালটা যতক্ষণ খোলা রয়েছে, অর্থাৎ যতক্ষণ ওর থেকে আমি কোনো কারেন্ট ডেলিভার না করছি, ততক্ষণ কি হচ্ছে? so long what is happening, some amount of coal is being burned to rotate it because it's a very high inertia, moment of inertia, it requires good amount of energy to run. Then what is happening to the system? I am not getting any electrical energy. So the complexity of the problem is that I am not getting anything, but I am spending some of energy in the entire conversion process. Am I right? Is it understandable to you? Then what is happening to that, which is going inside in the energy conversion process? What is that? তোমরা প্রবলেমটা বুঝতে পারছো তো? এর মধ্যে কিছু একটা আছে নিশ্চয়ই। ঠিক আছে, আমি বলছি। This is basically the inherent loss of the system. Whenever I am doing some energy conversion process, the system itself, which is carrying out the conversion, takes some amount of energy. That means whatever be the input, you cannot get exactly that output. Even for chemical energy, whatever energy it is hidden inside coal, you do not get everything of that. Some amount of heat energy is lost. Some amount of steam energy is lost. Some amount of electrical energy which is still generated, even so long if you do not draw even any current, for basically maintaining the auxiliary supply system, some amount of energy is lost. That we call the auxiliary system of that. And in thermal plant, it is almost 8%, 7 to 8%, which is we call auxiliary loss. So whatever generation you need to make, you need to give more input of that. So whenever there is an energy conversion process, some loss is associated with that. Am I clear? Right. মানে আমি এটাই তোমাদের বোঝাতে চাইছিলাম যে যে কোনো এনার্জি কনভার্সন প্রসেস যাই করি না কেন, the amount of input energy must not be equal to the amount of output energy. So in the process of energy conversion, some amount of energy is lost. That is truly applicable in any kind of energy conversion. But energy cannot be created, cannot be destroyed. So what is happened? It just gets converted from one form to another. And in our case, the most loss takes place in the heat form, either radiation, either convection. Can you hear me? আমার কথা শুনতে পাচ্ছ? অ্যাকচুয়ালি আমার কম্পিউটারে চার্জ চলে গেছিল, এটা খুব ঝামেলা করছে, তো যার জন্য ওইটার থেকে আমি বেরিয়ে গেছিলাম, আবার আমি চার্জে বসিয়েছি, বাইরিসটা আমি মোবাইল থেকে তোমাদের ধরে নিয়েছি। সো মানে আমার খুব ঝামেলা যাচ্ছে, আমার দুটো কম্পিউটার দেখছি ডাউন হয়ে গেছে। It's really very sorry state of affair. Anyway, what I was going to tell, I will soon be back to computer. তো যেটা বলছিলাম সেটা হচ্ছে যে we were discussing about energy conversion process, and in this energy conversion process what happens that some amount of energy is lost and some amount of energy which gets converted. Now we will be studying একটু বাদে ইকো হবে। Now I am back to my computer again, and I'm switching off myself. And so in our course we will be studying basically energy conversion in thermal generation. Particularly we'll stress on this turbine. The boiler portion, perhaps you are aware that when coal is put inside the boiler and we allow the coal to burn, it releases energy. It releases energy through the process of combustion, and we see that total combustion of the coal should take place. So in view of making complete combustion, we send the coal in powdered form, that is pulverized fuel form. Now this PF boiler, where the coal is put inside the boiler, it cannot get ignited automatically. So initially the coal is made to hot by allowing some more inflammable material, that is, we allow some LDO, where ignition do take place through an igniter, and the local heating takes place, on which, when controlled air through ID and FD, ID means it draws air, FD means it allows air inside the boiler. Through this FD and ID fan, what happens? The air, that is oxygen, is pushed into the boiler, so that there is a combination of air fuel mixture, and with the adequate temperature rise, coal combustion take place. And it is very keenly noted that in the heat generation process, that is chemical to make heat energy conversion, entire combustion do take place, complete combustion do take place. Otherwise, unburned fuel will go out, and carbon monoxide instead of carbon dioxide will be generated, which is really creates much loss in the system, because carbon monoxide, when it gets converted to carbon dioxide, it releases further heat. So complete combustion of carbon do take place only when the adequate quantum of carbon dioxide do come out. So we call it a stoichiometric ratio, that 12 gram of carbon mixes with 32 grams of oxygen and releases 44 grams of carbon dioxide. So based on that, we get the heat, and it releases heat. Now the heat, how it gets collected? It collected in the boiler system, where the pipes, steel pipes are there, which is basically in vertical composition. And perhaps, have you seen boiler? Anybody of you, have you seen big boilers? Have you done any planning or a visit in a thermal plant? How many of you? Please raise.
In virtual program of NTPC.
NTPC তে গেছো? কোথায় গেছো?
স্যার মানে ভার্চুয়াল প্রোগ্রাম ছিল ওটা।
ও ভার্চুয়াল প্রোগ্রাম, ফিজিক্যালি কখনো দেখার সুযোগ হয়নি তোমাদের?
না স্যার।
ইয়েস স্যার, ফিজিক্যালি দেখেছি।
সম্বিত দেখেছো? কোথায় দেখেছো? হলদিয়া এনার্জি লিমিটেডে দেখেছো, ভেরি গুড।
ইয়েস স্যার।
কিরম দেখলে?
আমরা স্যার বিবিজিএস এ দেখেছি, বজবজ জেনারেটিং স্টেশন।
বজবজে দেখেছো, ভেরি গুড। আমিও বজবজে ছিলাম, হলদিয়াতেও আমি গেছি অনেকবার। সো তাহলে তোমাদের দুজনের একটা আইডিয়া আছে, যারা যেতে পারোনি তাদের অতটা আইডিয়া হয়নি যে একটা বয়লার কত বড় হতে পারে। নাও ফর এ 250 মেগাওয়াট মেশিন, দ্য বয়লার ইজ বেসিক্যালি এ 17 স্টোরিড বিল্ডিং। মানে আমাদের বজবজের যে বয়লারটা 17 তলা বাড়ির মতন, 54 মিটার হাইট, এবং একদম বয়লারের ওপরে ড্রাম থাকে, যে ড্রামটাতে বেসিক্যালি স্টিম টু ওয়াটার কনভার্সন মানে টেক্স প্লেস। আমরা বয়লার থেকে যখন স্টিমটা বার করি, তারপরে সেটা যায় সুপার হিটারের মধ্যে দিয়ে, তারপরে সেটা আস্তে আস্তে বিভিন্ন রাস্তা ধরে আলটিমেটলি ইট গোজ টু দ্য টারবাইন। নাও হোয়াট ইজ ডান ইন টারবাইন and what type of steam goes? It goes superheated steam, and which is basically of 540 degrees centigrade and almost 143 kg pressure. So this high pressurized steam with very high temperature, 540 degrees centigrade temperature and 140 kg, almost 140 kg plus pressure. So it has got a huge heat content inside it. What is the heat content? What the heat content is called? It is called the enthalpy. That the heat inside the superheated steam, which acts like a gas, not like water vapor. It acts like a gas. Now, when it gets impinged on the turbine blade, huge amount of energy gets transferred. How it gets transferred? Because good amount of work done is created over there, which is basically due to drop of pressure and drop of temperature. So with this drop of pressure, drop of temperature, what happens? That the boiler, that the turbine starts moving. And there are 3 stages of this turbine. One is HP zone, one is IP zone, and the other is LP zone. Now what happens? That HP zone the area is much smaller, because when the pressure is very high, steam content is low. But when the some amount of work is done, when the steam releases some amount, steam, we should say the superheated steam releases some amount of energy, what happens? Its pressure reduces. Now, when the pressure reduces, what happens? Its volume increases. So IP is basically larger than HP area. And ultimately, that is intermediate. And when it goes to a much reduced pressure and reduced temperature, that means when it has given major part of its heat, but it still contains good amount of enthalpy, the entire thing we intend to get extracted through LP. So there the volume is more, but all are coupled on the same shaft. So the rotational RPM is same, although there is, the difference in diameter of the HP, IP, and LP turbines. So this is the nozzle. You have already understood that there is a nozzle. We will give you presentations. We will give you inputs that what are the mathematical formulae which takes place, and while releasing the mechanical energy, that what blade angle the steam gets impinged, what blade angle it gets reduced. Now ultimately these goes out, because the steam after LP, when they have reduced their energy content, completes their services. Now what happens? They are at low temperature. Low means it is not that low. It is like our simple drinking water. It is still at a temperature of 240 to 250 degrees centigrade, but it loses its capability of doing further job. Now the steam is taken away, but there are heat exchangers which gives away the heat of the steam, which is unable to do anything more technical, anything more mechanical activity in the turbine, but still their contained heat, when are taken away to the base, to its maximum possible through various heat exchangers, which again heats the boiler feed pump water lines. So what we do, when we push the boiler water through boiler feed pump, it already has gained some amount of energy, so that in the entire cycle, which is continuously operating, the heat input should be as minimum as possible, and we should not lose any amount of heat energy. So ultimately, after superheater, what happens? We need to cool it down, because we need to make it useful water, which is basically the boiler feed water, which is a very costly water, because boiler never allows any impurities to be inside it, because that impurity, if it is inside it, it ultimately impacts the turbine, and the turbine is a very, very sensitive and costly element. So if there is impurities in the steam, basically if there is impurities in water which gets converted into steam, if the steam impurities gets impinged on the very sensible turbine plates, which is running at an enormous speed, that is 3000 rpm, 50 cycles per second, then there will be possibility of imbalance of the turbines, and the entire system, which is having several crores, which takes several crores for its purchase or as capital cost, will go haywire. So this is a very, very sensitive devices and have a lot of protections to take care. The water management system is also equally strong, so that there should not be any impurity which is not desirable to be in the boiler system. Boiler water has to be taken with due care. So this is the process. Next day, I will discuss on the turbine possibilities and how the system to take place, how energy gets released. Before that, I will give you the presentation so that you can also read it in your home. Now, I will come up with the rest part of my presentation so that you can also have a glimpse of the Indian power sector, right?
Yes, sir.
এখন অবধি যা বললাম বোঝা গেছে তো, কোনো অসুবিধা নেই তো?
না স্যার, ঠিক আছে।
ফাইন। আচ্ছা, তোমরা দেখতে পাচ্ছ? Can you see the screen?
Yes, sir.
Are you seeing the screen in full or part?
Full.
Okay, fine. So last day we stopped on page number 14. Now sectorial division of electricity activities. I started this page. We are having generation sector, transmission sector, distribution sector, and operations. There is no such conversion, only the flow of
Sir.
electricity. Yes?
স্যার স্ক্রিনটা ফুল হয়নি স্যার।
হ্যাঁ, আমারও তাই মনে হচ্ছে। এক সেকেন্ড হোল্ড করো। এখন পুরো দেখতে পাচ্ছ?
হ্যাঁ স্যার, এবার ফুল স্ক্রিন আছে।
Okay, fine. Now, sectorial division of electrical activities. Here we are having 4 division. One is generation, one is transmission, one is distribution, and the last one is operation. Now, what the generation does? The generation does taking care of generation. It may be whatever may be the form of generation, as you understand that it may be thermal. In India, there are huge amount of thermal. Normally, we are having more or less 55-56% of thermal, and if you consider by the installed capacity, if you consider the energy capacity, is almost 77%. Now, transmission, and apart from thermal, what else are there? There are various types of other generations like solar, like wind, like hydro, like microhydel. There are generations on renewable, like bio biofuel generations, and many such things. And in fact, we are also having some amount of nuclear generation. We are thinking of increasing nuclear in the near future. And there are other areas which are researches are being on, like hydrogen fuel, hydrogen generation through hydrogen, and many things else. We are also trying to add up a little bit on like chemical resources, like setting up big battery banks for managing peak demands, or making the ramp rate uniform. That perhaps it will come gradually. Will come to know how these things are made possible and how these things are helping in India power grid. The whatever generation we make, we need to transfer it to the load center. So we need to have a good amount of transmission network, and it is a different business. People or various government sectors, it may be state, it may be central, they're in the process of commissioning large and big high voltage transmission lines to transfer bulk amount of power from one location to other. The last one, the final one, is distribution. So whatever power you generate, whatever power you transmit, ultimately it should reach at the consumer end. So it is the job of electrical people, so that they should work in the distribution field. Many of us do work in the distribution field. I myself also have worked, and it is the responsibility of the companies, distribution companies, maybe it's state control, maybe it's private, to transfer electricity from the transmission points or large substations to the domestic or industrial or commercial consumers. So the number of consumers are more than the number of generators, than the number of transmission lines. So complexity of the distribution is very high, and they need to do with millions of customers. And all the 3 activities, generation, transmission, and distributions, are so the generation, transmission, and distribution controlled by one group of people. They are named as operation. And the importance of operation is very high, so that they can take care of the entire thing. Now, in the distribution, what happens? As the distribution is very complicated, and it is ultimately giving you the power and taking the money back from millions of customers, there is a lot of disparity between the power supplied and the revenue back. So there is the little bit difficulty in this distribution. So there are losses, huge losses, and delay in getting the money back. So these are the problems in distribution. Now, the distribution, what is named as loss, means aggregated technical and commercial losses. What is technical losses? That is whatever loss do take place in the transmission, in the conduction process. That is the Ohm's law. Now, if the wires are very long, if the wires are of inferior quality, the resistivity of the wire is more. So high resistance means I square R, that is the heating loss is more. So the technical losses get more. and more number of distribution transformers and transformer with inferior quality materials, there the losses are more. If the joints are bad, the losses are more. Every joint do get some amount of additional heat losses which are distributed in nature, but if you take in a cumulative value, the value becomes high. Not only the technical losses, there are commercial losses, which is basically meter reading. If the erroneous process of meter reading, if many meters are not read, and if meters are read which are readings running slow, and if there are millions of consumers, you should read millions of meters, and there may be snags. If 10% meters are not there, or the 10% of meter readings are wrong, say of lower size, there will be huge losses, and there may be other malpractices too. So what happens in India, and an average distribution losses, ATC losses, is above 20%. So whatever power you produce, you get only financial return of 20%. So the distribution companies are usually reeled under losses. Now the government is taking every steps how to improve the distribution's condition. So there are many ways how to making the process improved. One process is called DSM, that is demand side management. When the process is, the loss which is being incurred at the customer's end, when you try to improve some modern technology and mechanism so that the loss at the distribution end reduces, which ultimately reduces the loss of the overall generation and transmission system. So it improves the economy of the process. Now I am showing you a curve which is basically the blue line you see, that is the all India demand curve. That is, if you go on taking the demand on hour-to-hour basis, ultimately throughout the day the demand indicates a curve, and which is peak in the evening. Now we are thinking of putting up, say, 100 plus gigawatt of solar energy in our system. Now, if the peak morning load is 210, and if we put morning peak at 100 gigawatt solar, then what happens? The thermal generation, which is so far feeding, thermal or hydro, which is so far feeding our load curve, will suddenly be, put down, will be put below, or reduce. They need to reduce their generation to accommodate solar, because you are not increasing the demand, you are only increasing a parallel source of supply. So the existing source of supply, which is thermal, need to be reduced. Now the problem is that in the day period you are reducing thermal, and in the evening period you need to increase thermal, because in the evening you are not getting any solar, you are getting solar only at day. So what happens? You need to make the conversion, energy conversion, in the evening period, or on the onset of evening period, as soon as the solar is drooping, at a much faster rate. We call the rate of rise of demand, and matching with the rate of rise of generation is that ramping rate. You understand what is ramping rate? That is the rate of rise of demand. And if you want to meet the rate of rise of generation in line with that, you need to increase the generation very, very fast, which is very difficult in thermal process of conversion, because it is heat related generation. So that you need to heat up the entire process. You need to add more and more fuel into the system depending on the load rise and depending on the quantum of solar generation falling. So it is a very difficult process. So we need to add further addition of further energy conversion process in the system. We need to add hydro, which is basically valve controlled. And so if we have enough of hydro support, we can match up with the ramping rate. And additional what is required, what we can put into, that is addition of battery banks. So that when there is the battery will go on supplying current depending on the fall of voltage, and the battery will be sensitive up to that when the thermal is yet to pick up. But that amount of very big battery is not yet produced in India, and it is a very costly process. So the engineers and we people working with the power system are running with the challenges. I am just giving you this idea just to get a hint that what are the challenges in energy conversion in India. Do you understand that? Could you understand it?
Yes, sir.
পুরোটা বুঝতে পারলে কি বললাম?
হ্যাঁ স্যার।
ফাইন। তাহলে এটা আমাদের একটা চ্যালেঞ্জ এবং আমাদের কি কি দরকার ফিউচার ডেভেলপমেন্ট ইন জেনারেশন হোয়াট উই নিড I may ask questions on that. In generation of electricity, what we need, that is in the thermal conversion process, we need to make the process more efficient. Now the efficient of subcritical, that is where the temperature of is below, the 283 degrees centigrade, where the water directly gets converted to steam without using the boiler drum. This is called subcritical. And in supercritical, when there is in the boiler tube directly water gets converted into steam and there is no drum, it goes directly to the superheated tube. Their temperature and pressure are more. So these supercritical, in the process, the efficiency is improved. At least 2 to 3% efficiency gain is observed. And if this is in a very big generating unit, then the efficiency level goes higher. So the effective output becomes higher. Suppose if 600 megawatt supercritical, where the earlier efficiency was 36%, 38%, now the efficiency is more than 40%. So 4% of 660 is substantial quantum what you are getting additionally through this supercritical system. So supercritical boilers with higher efficiency and having ability to burn inferior quality of coal, environmental safeguard on gas emission and effluents. Here, this is a objective. So in the energy conversion process, when you will be, any one of you are working with the thermal process, you just keep in mind that these are the things we need to do in future. Hydro and renewable generation, that also needs to be increased because we are focusing on green generation. Thermal generation is, creating more pollution, creating greenhouse gases, so we must resort to more green energy, which is through renewable and hydro. We are looking after tidal wave, wind energy, geothermal, microhydel, but geothermal, tidal, these are still on experimental level. Not much job has been done, and I am still afraid that how much is the source of tidal and geothermal resource in India, and they are very costly also. Storage and battery, very important. Fuel cells, superconductivity, flexible solar panels, we are working on it. Generation from alternative fuels like husk, sugarcane, fiber, even from garbage, with having little bit calorific value. So these these activities are being done. So these are coming up in future. Now in distribution sector, distribution of electricity is, it's a quite challenging job in India. Bring down the ATC loss in distribution sector, less than 10% like all modern countries. This is also important. So we need to change the metering, billing and collection system, MBC system, backed by IT, automation and improved manpower quality. Customer focus is very important because when you are supplying, distributing electricity and taking money from the customers, you need to have a customer focus. So that is still today customer focus is there, but earlier it was absent. Now we need to improve the focus because customers are the only thing who are buying electricity from you. And in future, if competition comes, we need to more focus on customer support. Energy efficiency and solar and renewable energy integration within the distribution network, that is making the distribution more, energy efficient and more, more distributive towards the society. We need to have more renewable added up in the system, like rooftop solar, like where wind energy is available, you can put inside the distribution body a generating wind farms where you can also collect energy. So earlier the distribution system was basically unidirectional, from where you collect energy from the generating through transmission, you transfer that energy to distribution point, from distribution point at a lower voltage you transmit to the consumer. Now between the consumer or at the consumer end you also give generation. So consumer is not a consumer. He has become a producer and as well as a consumer. So the name has been changed. They are known as prosumer, who are produce electricity and consume electricity. So now this is an integrated system. This system has come in India. You know that there are solar parks, you know there are the rooftop solars, and how the rooftop solars are connected. They are connected through net metering. Now, how much you are producing, how much you are generating, that should also be logged to the local distribution control system. Otherwise, they won't be able to gauge how much renewable power is being generated. So you need to have absolute strong metering system. It is being in vogue, although it is not well practiced, but with the usage of smart metering and communication technology, that is with the integration of smart system, this is being implemented, which is a part of the smart grid. So we need to increase more automation, more networking, more IT applications, and more communication-based systems, so that there will be much faster information exchange, and the grid will be more resilient and can be able to take decision. The grid will act like an intelligent network. It will try to take decision on its own to avoid any indiscipline and any debugger. So this is a part of the smart system. Now, distribution, if you become more efficient, the distribution load will fall, because earlier you had losses, now more losses, now you will have less losses, so your energy demand will go low. Now, what will increase the energy demand? Again, the energy demand will increase. How? Through electric vehicle. You convert electric vehicle means you are reducing the oil requirement. You run your system on electricity. It will cut down your oil bills. It will cut down your expenditure. At the same time, it will increase your electricity generation. And that will be best applicable if you put the charging mode through solar generation. So that will be a green generation, which will meet but there should be a very good charging infrastructure, charging network. And same with the water purification system, and many systems like electric cooking are coming in vogue, so that you can replace your gases with electric cooking. But when you can do that, if you find it is economically viable. So this conversion of energy, which is being imminent, will come at a cost parity. So in future, we are thinking that if more solar do come in our system, the cost of solar price will go down. That will one day will be able to replace the gas cost, and the major energy of cooking can be done through electric cooking, which will be a safer, cleaner, and more green system. So thank you very much for this day. Next day, I will come up with the courses, and I request Deb Malla to share me his mail ID, so that I can one by one send the required input to you, which will be helping you in future in answering questions and understanding the subject.